You know, we're surrounded by all these systems designed to keep us safe, a lot of which we never even see. But some of the most critical ones are the ones that have to work perfectly just once in that one moment of crisis. Today, we're going to look at one of those, the unbreakable rule that connects a fire alarm to a locked door.
Okay, so imagine this. You're in a modern office building. A fire alarm is just screaming and you run for an exit. But it's a secure door, one that's normally locked tight. Is it going to open for you? Well, the answer to that question is not left to chance. It is a life or death engineering problem.
So, how does a building guarantee that door opens? It's all dictated by a very specific interface and an incredibly strict set of rules. This isn't about fancy software features or convenience. We're talking about a fundamental promise of safety. To really get this, we first need to talk about the type of lock we're dealing with. It's called a fail-safe lock. A perfect example is that big electromagnet or maglock you see at the top of a lot of glass doors. The key idea here is super simple. It actually needs power to stay locked. You cut the power, it unlocks. That one property, well, it's the foundation for everything else we're about to discuss. Now, how these locks have to behave isn't up for debate. It's all governed by the National Fire Protection Association, or NFPA. Their life safety code is the absolute authority, and it lays out in no uncertain terms exactly how these systems have to perform when there's a fire. The whole code really boils down to three crystal clear non-negotiable rules. First, the release has to be immediate. No half-second delays, no thinking about it. Instant. Second, it has to be a positive release. This is huge. It means the power has to be physically, mechanically cut, not just a piece of software telling it to unlock. And third, it's got to be latching. This means the doors cannot, under any circumstances, relock on their own, even if the alarm gets silenced. These three rules are our checklist for a safe system.
Okay, so here's where it gets really interesting. There are basically two ways installers try to connect a fire alarm to these locks. One of them follows the rules perfectly. The other, well, it seems logical on the surface, but it's actually a really dangerous trap that completely violates the code.
This lays out the two approaches perfectly. Over on the left, you've got the power cut method. This is all hardware. The fire alarm physically severs the power to the lock. It's just simple, reliable physics. But on the right, you have the input trigger method. That's all software. Here, the alarm just sends a little signal to a computer, and the computer has to think and then react. The core difference? Independence versus dependence.
All right, let's start by walking right into that dangerous trap, the software method. This is a mistake a lot of people make, and it's so important to understand exactly why it's just so wrong. So in this setup, the fire alarm is just wired to an input on the access control computer. When that alarm goes off, the computer's processor has to actually see the signal, then it has to run a little line of code that says, hey, if this happens, then do that. And then it has to send a separate command out to unlock the door. You see? It's a whole chain of digital logic.
And that right there, that's the whole problem. This entire sequence, from start to finish, hinges on a computer's processor working perfectly at the exact moment a fire breaks out. And that is its single fatal flaw. So why is that dependency so incredibly bad? I mean, what if that computer is in the middle of a reboot when the alarm sounds? What if the software has some random bug and it just freezes up? In any of those cases, that command to unlock the door never gets sent. The doors stay locked. This setup violates the immediate rule because of that processing delay, and it violates the positive release rule because it's not a direct physical action at all. Okay, so if that's the dangerous way, what's the right way? Now let's look at the industry standard, the hardware-based power cut method. This is how a truly safe system is built every single time. Just look at how beautifully simple this is. The fire alarm panel has a little thing called a relay. It's basically an electric switch. When the alarm triggers, that switch physically flips open. And that action breaks the electrical circuit that's powering the locks. That's it. 2 steps. The electricity stops flowing, the fail-safe lock lets go. Done. And here is the absolute genius of it. This method is 100% independent of the access control computer. I mean, that computer could be frozen, it could be unplugged, it could literally be on fire itself. It makes absolutely no difference. The power cut happens at the hardware level, guaranteeing those doors open no matter what. It is bulletproof. But we're not quite done. There's one last piece to this safety puzzle. Remember that third rule we talked about? Latching? This deals with what happens after the smoke has cleared and the alarm is finally turned off. So,
The fire department gives the all clear, they reset the alarm system. Should the doors just automatically lock themselves up again? Well, the fire code says absolutely not, and there's a very, very good reason why. The reasoning here is so critical. A fire might flare up again, or firefighters could still be moving through the building. Automatically relocking the building could be a disaster. It could trap emergency responders inside or block them from getting back in if something else happens. The system has to fail to a safe, unlocked state and just stay that way. And the solution to this is that latching logic. Once the power is cut by the fire alarm, it stays cut. To relock the building, a person in charge, like building security or a firefighter, has to physically go to a panel, often with a key, and manually reset the system. This forces a human being to make a conscious, deliberate decision that the building is truly safe and ready to be secured again. When you really boil it all down, what this all comes back to is a really powerful principle. When lives are on the line, complexity is your enemy. The simple, direct, hardware-based power cut is just infinitely more reliable than some complex chain of software commands. Simplicity is safety.
In the end, it just comes down to a really simple choice, doesn't it? When everything is on the line, what do you put your trust in? A line of code that might fail, or a fundamental law of physics that can't? The fire code has already made its choice. Thanks for watching.